It's all your fault, Miss Fifield.
Everything is my fault, and it's been my fault since I was 5 years old, so I'm used to it. I promise, I'm used to it.
All right, so King Henry died drinking chocolate milk,
Oh,
and that's the conversion. You remember that, don't you, from class?
vaguely. I got halfway through the Section 8 homework, and
Well,
I
here's
remember some of it.
there's an example there, and there's an example there.
Okay, can you please leave it up front so I can
Yeah.
find it? I'm sorry.
I know, I'm moving it.
No, I'm sorry. I don't like being late. I'm being early.
Hey there.
Hey.
The other two girls are down in the computer lab.
That's fine.
Is it because your video stuff
That, you can
wasn't
go down
working?
there and
Hmm.
tell them to take their time.
Well, they just started the test, so it's gonna be a while.
All right, so if you have 1.2 kilometers and you want to change it to meters, you sit here and you count until you get to the meters, and that's how many times you move the what? Decimal. Here, 25, there's the decimal. I want to go from millimeters to kilometers. 1, 2, 3, 4, 5, 6. And I move it 6 places to the what? 6 places to the left. This one I moved it 3 places to the right. 1, 2, 3. And this one I moved 6 places to the left. And that's how you do those conversions. I'll put a lot of these on the test. These are not hard. This is, and for your information, I'll put it back.
Thank you.
8.1, 8.2, and 8.4 is what I'm gonna cover.
On the test, okay.
In the homework, I'll say, do not do 8.3, because I'm not gonna even go into 8.3.
Oh, cool. I think I was getting ready to start that one. So,
Oh, the reason I have these X's here, they not usually, in the real world, these are not usually used a lot. These are kilo, which has to do with, your swimming pool, how much your swimming pool will hold, that would be a kilo what? Liter. A mile or distance would be kilometer. A ton or something big would be kilogram. That's big things. Big things are measured in kilos. Small things, centigrams, centimeter, centiliter, not used very much. Milliliter, used a lot. Millimeter, used a lot. Milligrams, used more than centigrams. Okay? This is your basic unit. This is your equal to 1. 1 meter, 1 liter, 1 gram. There's 10 decimeters in a meter. There's 100 centimeters in a meter. There's 1,000. Each one of these is base 10. Tens, hundreds, thousands. These are the THs. Tenth, hundredth, thousand. This is your tens, hundreds, thousands. And that's how you use, and remember, I told y'all, chapter 8 and 9, I'm going to go through real quick because I'm not going to sit up here and do 15 of these when y'all understand it. There's no sense in it.
right.
Let me pull up a couple of problems and we'll do a couple. Like these, I'm not gonna, the freezing point, oh, well, no, that's not what I want. They ask you stuff like, what is they'll ask you some things like, what is a paperclip measured in? You know, that kind of stuff. I'm not gonna do those. The kind of questions I'll give you are these right here. 1 kilogram equals how many grams? Well, that's 1,000. These are basic. I'm not gonna ask, well, here we go, right here. Convert the given unit to the unit indicated. 9.2 meters to kilometers. So let's do those. I'll blow them up for you. We're gonna do every one of those right there. 39 through 44. Won't take but 5 minutes to do it. But go ahead and write them down. We're going to use that white area over there to do them.
So write them all down.
Write all of those down. These are your examples for to do homework. Oh, I can't.
Is hectograms HG? Like, how do you abbreviate that?
I'll just go ahead and write them down and I'll show you. There's a page you can go to that has all of them.
Okay.
And the reason I don't know hectograms is because you never use it.
Okay. Got it.
In millimeters is mm.
Yeah, I know that.
Milliliters is ml.
Yeah.
The dm down there, I believe that's decimeters. I think that's h. But I can't remember. Let me just go right quick.
Is it HA?
I tell you what, hold on. Let me freeze this, and then I'll go find it for you.
No, hectometer is at HM.
895 liters to milliliters. What'd you say?
Hecto is H, but hectometer is HM, so a hectogram would be HG.
Yeah, that's what I'm getting to. Hold on just a second. Okay, turn to page in your book, page 436.
What is that?
Is the classroom next door?
Page, hecto is H by itself, just H. I thought it was H. It's deca. Deca is DA. Deca is DA and deci is D. That's the one you have to remember because they both start with a D.
So if it's a hectogram, it would be HG.
Mm-hmm. I just got your text. I'm sorry.
That's okay.
We would have been here sooner, but the receptionist was taking forever with the one person in front of me. I was staying in line for like 15 minutes, just trying to ask her where the hell you were.
Well, I'm sorry. I thought
No, it's fine. It's just
I thought that note, we put a note up in the room. I thought it was still up.
No, there's no note there.
Well, we're gonna meet here next week because nobody meets in here and this computer don't mess up, so.
Does it feel weird being at your other classroom?
No,
Okay.
but I'm not gonna ask for that classroom. Cause there's something wrong over there.
I'm convinced my store is built over an ancient burial ground because crap just keeps malfunctioning over there for like the last 2 months.
No, what about the nines? We do all of those for our homework?
Yeah,
9.1.
I'm gonna touch on those.
Okay.
Alright, so I'm gonna get out of this and I'm gonna bring that back down. So I can draw. There we go. Alright, there's my problems. I'm gonna slide them over to where I can draw. Well, I guess I'm not gonna slide them over. Okay. So, King Henry died drinking chocolate milk. Write that out. And I'm gonna write it out real small because I don't wanna. Let me write it out up here. King Henry died, meters, liters, kilograms drinking chocolate milk. All right, let's go with the first one. 9.2 meters. So where are we going to start?
In the center.
In the center. And we're going to move to milli. 1, 2, 3. So that would be 9.2, 1, 2, 3. 9,200. Simple as that. Question? Everybody good on that one? All right, next one. Kilograms. Where we're going to start?
The K,
With the K. And we're going to move to hecto,
which
which
is
is, where's,
H.
oh, there it is. One place, and I've never used hecto. And that's 693. We good?
Mm-hmm.
Liters.
In the center.
Mitter, and we're going to move to 1, 2, 3. So that would be 895. 1, 2, 3, and 3 zeros. Now, be careful here. D by itself is what? Isn't it deci?
Mm-hmm.
So DA is deca. So decimeters is right here, and we're going to go to kilometers. 1, 2, 3, 4. So we got to put 4 places. I don't forgot right here. So 24. 1, 2, 3, 4. So 0.0024.
So the decimal is always after the last zero that you place?
On a whole
Or-
number, yes. On whole numbers, they're always right there.
Okay.
Milliliters to decaliters.
Okay.
Now, deca is right there. So, we're milliliters. 1, 2, 3, 4. So that's going to be 1, 2, 3, 4. 4.0302. And then milliliters to what?
Liters.
So milliliters is right here. 1, 2, 3. So 1, 2, 3. So 0.000034. Right?
Yep.
Now, if you can do those, you're good for the test. This is one of those sections that I think you could have got by without me teaching. Just reading the chapter. I'm looking to see if there's anything else I need to cover. So that's all this section is. I wanted to see, okay, here's some examples of, they used to ask like swimming pool. Well, you just have to look through the homework and they'll ask a question like, what is your swimming pool measured in?
Had one of those.
That would
on
be
my
kiloliters.
homework.
Hmm?
There is one like that. on
Okay.
my homework.
What is a Coke, a regular size Coke measured in? That would be liters. Like a 2-liter Coke. I remember when the 2-liter Cokes first came out, everybody was like, 2 liter? Looks like 2 quarts to me. You know. But anyway, I'm not going to ask a lot of crazy questions on this. It's pretty straightforward, basic. Well, what about the next? Well, this is the one that I really don't need to spend a lot of time on. Length, area, and volume. So I'm going to go through and we're going to talk about length, area, and volume. And I'm not going to spend a lot of time on it. Because like I say, a lot of it you should already know from your K through 12. So let's go with clean sheet, and I'm gonna put 3 things up here. I'm gonna put length, and I'm gonna put area, and I'm gonna put volume. Now, I grew up surveying. That was, I mean, the business that my daddy owned is the same age as I am. It was started in 1966, and I was born in 1966. So, where is the move? Oh, come on. There it is. Now, why am I telling you that? Well, when you work with people, you start to figure people out. And there's some things you can figure out. And one thing is, when somebody owns less than an acre of land, they start to fence in everything. Okay? Most of you farmers, they have fences, but that's to keep cows in. If you go over on their land, the farmer, he ain't gonna care unless you're just doing it to aggravate him. But most of the time, people with 5,000 acres or 100 acres or whatever, they usually don't care if you walk across their property. Oh my God. Go into a half acre. Oh my God. You got 15 dogs in the back, and you'll wonder why I hate dogs. Try to survey a piece of property with 15 dogs in the backyard barking non-stop. You just want to take an axe and cut their heads off. Okay?
Animal cruelty.
Yeah. Well, I'd rather use the handle. That way it wouldn't kill them. I don't kill dogs.
Wrong.
I actually love animals. I just don't care nothing about dogs. All right. So length is going to be like a fence. We call it perimeter.
Really?
Perimeter is a 25-cent word for walking around the what? The property. Or I'm just going to say walking around. And usually when people buy a piece of property, what's the first thing they do? They go buy some fencing stuff and they put up a fence. Okay? Now, so, and the reason I say length is that's what you measure the perimeter in. Whatever if you're measuring in inches, then it's going to be in inches. You are a small, yeah, you're an idiot. But anyway, you measure your property in inches, and you. No, we're not
Did
going
you
there.
measure your pool in inches?
Yeah. So,
No, you measure your pool in gallons.
No.
the liters. She's talking about perimeter of the pool.
You know, the haystacks he's got?
Yeah. Okay, so perimeter is walking around the property and you just add up all the sides. I'm not going to give you a formula for that, 2L plus 2W, but basically you're going to add up all the sides. Now the only one that's different is the circle. And the circle, you can find the formula for that, I believe it's pi r squared, I think. Look on the inside cover of your book or look in the section that we're on and you'll see the circumference, it's called circumference of a circle is the same thing as perimeter. Okay? Y'all don't have an inside cover anymore, do you?
Probably not.
No, because y'all get done away with the hardcover. But just look in there somewhere. It's on the edge of your page. You don't mind me manhandling your book, do you? Might be in the next section. What section are we in?
This is
Like
8.2.
Okay, maybe in 8.3. It's on the side of the page. That's not it. When I see it, I'll know I see it. It should be on the side of the page. And I'm getting irritated. Okay, you're going to have to find it somewhere else. Or you just Google it. Here, let me just show you how to do it. Just go to Google and type in perimeter of shapes. That's the easiest thing to do.
Pretty sure it's pi.
Perimeter of shapes. And it'll come up and then you can, here it is, here's a good one right here. Right there. There's perimeter of different shapes. You can write those down. Perimeter of formulas, however you want to, you can pull kinds of stuff up, videos on perimeter. Here's one that's got the formulas, and there it is, 2 pi r. Pi r squared is the area. So there's a good sheet right there. Just pull up perimeter. Not a big deal. And they have all kind of formulas for perimeter, but you just add up what? All the sides. Act like you're putting up a fence around your shape, and that's what perimeter is.
You said pi r squared with area?
Mm-hmm. Well, we'll get to that with the area, but yeah.
Okay.
We'll keep this page up because we're going to use it for area, and you can go print out whatever you want to. So the property owner has a ½ acre or less of land, and he puts up a 12-foot fence. Okay, huge fence, got barbed wire on the top of it. Got to keep people out. Well, he keeps people out, and then he decides he wants to go in the beef cattle business. So gets him a beef cow or two. What's that cow got to eat? Got to eat grass. Well, grass is what I like to call the area. Because what does the grass do to your property? It covers it, doesn't it? It covers the property. And when something covers, paint covering this wall, this area. Anytime you cover something, you're talking about area. And of course, that page right there that I just pulled up, you're talking about area, but most of the time, a quadrilateral is a square or a rectangle. A quadrilateral is going to be length times what? Width. Triangle is going to be half the length times width, because what is a triangle? Half of a what? A square or a rectangle. So those two are pretty much the same, except this one you just take half of it. Circle, what did I say it was? Pi r squared. Where r is the what?
Radius.
Radius. Okay. Now the reason I didn't give you any formulas for this is because you don't need a formula. You just add it all up. Okay? So his cows die because they don't know how to take care of them. And that's what happens. These people, we had a guy, they don't live in the community anymore, but he came out there, he was going to get in the beef cattle business. He bought like 10 or 15 cows, and just about every one of them died. Didn't know how to take care of them. Volume. Well, after his cows die, he's trying to figure out what else he can do for the property. So he digs a hole around the property and makes a swimming pool or a pond. I'm going to put swimming pool because you can actually see the sides of the swimming pool, so I'm going to say swimming pool. Digs out his whole piece of property and makes a swimming pool. Let me ask you a question. You still got your length times your width that you did the area as far as acreage, but what did you add?
Height.
You added height. But what about depth? Well, it all depends on which way you're looking. If you're in the hole looking up, it's called height. If you're standing on top of the hole looking down, it's called depth. So it's still the same thing. So swimming pool, you add a third dimension. And that's still your area, length times width, but you add that height. And you multiply, you add that dimension. Now that's a quadrilateral. 1/2, length times width times height, that would be the triangle volume. But with a sphere, because you go from a circle to a three-dimensional object with volume, you're talking about a basketball. Basketball is pi r(h) squared. And this, you can look it up. I'm not going to worry about it because we're not going to be doing it. All right? If you do, and we'll talk about pi, you're supposed to use pi. Don't use 3.14. Use pi. Use the key on your calculator. Now, let's talk about the dimensions. First, second, and what?
Third.
First dimension is length. Is there any other dimension? No. You don't measure length times width. You just measure length. So that's first dimension. So whatever you measure in, it's going to what? It's going to come out that same measurement. If you measure in feet, it's going to come out in feet. If you measure in inches, it's going to come out in inches. It's one dimensional. Well, two dimensions, you multiply the length times what?
Length times width.
So that's two dimensions. So your answer here is going to come out feet what?
Square.
Feet squared, because it's two dimensional.
I didn't know that. I never explained it that way. I
A
didn't
lot of
know
people
square.
don't know that. And what's the third dimension?
Cube.
There you go. And these are going to be measured in cubic feet, because you added that third dimension.
My high school didn't teach me anything. I've learned that.
Well, there's something about high school students also. They don't listen very good.
Well,
I was one of those.
this is true, and I fully admit that, but I swear I did not learn half the stuff I was supposed to in high school that I've learned in the last year here.
Well, I can only say I probably didn't hear it. I probably was taught it, I just didn't hear it. If you measure in inches, inches. Inches, square inches. Inches, cubic inches. If you measure in whatever, I don't care what it is, miles. If you measure in miles here, it's going to come out as miles. Miles here, square miles. Miles here, cubic miles. So if you see a subscript of 3 on a test, standardized test, an entry test, you know it's what?
Cube.
Volume. And you know it's got to have 3 dimensions. Okay? Now, I will give you probably a couple of questions on each of these.
Not a lot.
Okay, that's not hard. This whole chapter is not hard. Okay? All you got to do is just do some problems. That's why I'm not spending a lot of time on this chapter.
The hardest part for me of this stuff is the conversion.
8.4 is your conversions, because we're not covering 8.3. I've already covered 8.1, and it's on the video. Okay, so we go in 8.1, 8.2, and 8.4. That's what you got to do for homework, and that's what you're going to be covered on the test. Now, let's talk about 8.4. 8.4 is probably the most challenging out of chapter 8. 8.4 is called dimensional analysis. Now, dimensional analysis is a 25-cent word for going from metric to what? To standard, or from going to standard to what? That's what it is. It's when you are switching from one system to the other. Now, what about 4 cups is equal to 1 quart? That's not going from system to system. That's going within a system. King Henry died drinking a chocolate milk. That is in a system. So those are easy. Now, what if, what?
King Henry died.
Drinking chocolate milk. That's what I showed y'all at the beginning of the class.
Oh, I wasn't.
Say again.
I wasn't.
We wasn't in here.
Yeah, exactly. All right. There it is. King Henry died drinking chocolate milk. You just watch the video, you know, when I post it, you get and I did those examples, and I think I did 5 more examples. So they're on the video. Okay? But, let me just put it to you this way. Let me just write, okay, 4 cups is equal to how many quarts? And we know that 4 cups is equal to what? Is it 1 quart? I don't know. I thought it was 1. Y'all don't know?
I thought
I think it's 1. Somebody look it up. I'll Google it. Well, look it up.
Well,
Hurry up!
What is it? Cups to quarts?
Standard measurements. Standard measurements. There we go. Is that it? No, that's bust, waist, hip. What? Oh, they're talking about woman measurements. SI, let's go with SI. It's called SI. Here we go. International System of Measurements. That's not. Let's just type in 4 cups is equal to 4 cups is equal to
Yeah,
what?
it's one quart.
Okay, I thought that was right. Okay. Okay, I still can't find it. You have to look and find
It's
it.
on page 463, but
Okay,
it don't
thank
say exactly.
All right, now, the reason that's simple is because this is your standard going to what? Standard. A while ago we did 4 millimeters is equal to 1, 2, 3, the 4,000, I'm sorry, 0.000, hold on. I went the wrong direction. 0.004 meters. Okay? Standard to standard, metric to metric. Those are inter-system. In other words, this is within the system of metric. This is within the system of what? Standard. So those, y'all don't have any trouble with. Usually, I show you King Henry died drinking chocolate milk. Y'all do 5 or 6 of these without a problem. You do 5 or 6 of these without a problem if you can remember them, because I can't remember them. All right? I can remember 5,280 feet is equal to a mile. I can remember 43,560 square feet is equal to an acre. Why? Because I grew up doing that. I didn't grow up cooking. All right? I didn't. But I can cook, but that's because I learned how. Not because I grew up. And I can't tell you how many teaspoons. There are 2 teaspoons in a tablespoon.
You tell me.
I have no idea. Okay? I have to look those things up. Now I do know that a half teaspoon and a half teaspoon is equal to a teaspoon. I know that. I know the fractions, but I don't know the conversions of cooking measurements. I don't. Now I could look at them and remember them, but I just don't remember them. So these are easy, but this is not dimensional analysis. This is it's called intra-system conversions. It's inside the system, and you can do those. This is whatever section 8.1. Now, what is dimensional analysis? Well, changing 1 quart into blank liters. That is dimensional analysis. And I'm going to show you how to do that. And it's basically unit conversions, which a lot of you nursing students are going to be doing.
Europeans have to do that because they're gallon, or
Yeah.
they're all on a different system.
Mhm.
When they come over here, they're like, oh.
English, they still measure in stones.
Really?
Mm-hmm. Some of the cultures over there, if you say stones, they know exactly how much you're talking about.
I met a lot of Europeans when I was at the hotel.
Oh, yeah.
They were like, oh. Yeah.
And they think we're all stupid down here in the South, don't they? Yeah, they do. I mean, a lot of your Asian people think we're stupid and lazy.
Whoa.
And a lot of your people from up north and over were stupid and racist. So
And eat dirt. My uncle from
eat
New York.
dirt. Now that's a new one on me.
My uncle from New York said he really thought that Southern people ate dirt.
I wouldn't doubt it. We stupid and everything. So, all right. So if I wanted to change 1 quart into liters, the first thing I'm going to do is I'm going to write 1 quart over 1. Let me change 2 quarts. Let me change that to 2 quarts because I don't want to use 1 and 1. So let me change that to 2 quarts or 2.5. Change it to 2.5. So 2.5 quarts is equal to how many liters? Well, the first thing I'm going to do is put it over 1. 2.5 quarts over 1. Now, why do I do that? Well,
'Cause you want
how
to
can we cancel in mathematics? We can cancel vertically and we can cancel diagonally. And that's what you want to do when you're doing unit conversions. In unit conversions, or dimensional analysis, in unit conversions, one of the things that you want to try to do is you want to cancel units. Now, you're not going to be able to cancel units vertically, even though we can do that with fractions. We cannot cancel units vertically because 5 quarts over 5 quarts is what? 1 whatever, but you can't cancel the units vertically because then you don't have anything. All right, so you can't do that. That's not legal with what we're doing. So you might want to take that one out. So that only leaves what?
diagonal.
And that's what you want to try to do. You can't do diagonal if you don't have a fraction. So you got to start out with a fraction. Now sometimes you're going to be given a fraction, like 50 miles per hour. That will be 50 miles over 1 what? Hour, and you're given 2 units. Here, if you're not given a unit per, then you just put that over 1. Now, something very important here. For uniformity, when you're doing 8.4 homework, make sure you use the 8.4 table. Do not use any other table except in the homework. You know, the online, they'll give you a table. Use that one. The table that I want you to use is, when I get there, is this 8.4? I gotta get to 8.4. Hold on.
Some page 465.
I'm getting there. That's the table. Now that's the table. Do not use any other table. The only table you can use besides this one is the one that's on the actual question. They'll say, click here to put for the conversion table. And you click there and it'll put this up right here. The reason is there are some rounding differentiations between tables that you find on Google. And in other words, they may have, see where it says 1 pint is equal to 0.47 liters, they may have 0.465 liters on another table. And then you'll be getting crazy answers and they won't match up. So, for you to get answers correctly, make sure you use this table in the book or use the table that they supply in the question. Okay? That's very important. Alright, so let's look. Are we dealing, in our problem that we're doing, what are we dealing with? What is quarts?
Volume.
Volume. So we go to the volume table, go down to volume, and find some kind of what? Conversion from quarts to what?
Liters.
There it is. 1 quart is equal to 0.95 liters. Well, let me tell you something. You've got 2 possible ways to write this down. And they are the wrong way and the what?
Right.
The right way. Which way can we cancel?
The quart on the bottom.
The quart has to be on the bottom because this one is what?
Quart
On the top, and you got to cancel diagonally. And that's what dictates where to put what.
The other unit.
So, 1 quart, the conversion says 1 quart is equal to 0.95 liters. Now watch what happens. 0.95 liters.
This multiply across.
Now, if you use the unit conversion canceling diagonally, what happens to your units of quarts?
They go away.
And that leaves what?
2.5 times 0.95.
What?
Liters.
Liters. And now you've converted. And that's how you do unit conversion. This one is basic. On a scale from 1 to 10, with 10 being challenging, this one's about a 1. Very simple. So your answer is, somebody take 2.5 times 0.95, that'd be 2.
2.375.
Okay, 2.375 is your answer. if everybody if everybody calculates that correctly,
2.375.
something like that.
So do we round to 2 places or?
Read the directions on that, because they will tell you. And I'm not gonna be a stickler if it doesn't say round to a, now the general rule, what is my problem in?
Liters.
No, decimal places.
One.
One decimal place. So as a general rule, if you start in one decimal place, you what? In one decimal place. What did you get? 2 point what?
375.
So it'd be 2.4.
Okay.
Now that's a general rule of thumb in
Well, now,
science
on that,
and in math.
On that other question that we did on one of our tests, you know, when we did it on the thing, we was like, don't leave the numbers off because the banks don't leave it
Yeah,
off.
that's
That
an
sounded
interest
wrong.
problem.
Yeah, that kind of wrong when
We-
you write out all.
You need to see me and I'll fix it. If that's on a test. If it's
Mhm.
on a homework, just do the problem over and do what they tell you to do to get the homework right. But if you do it on a test and it doesn't specify, if it says just find the solution and it doesn't specify rounding, then I need to see it to give you credit
Okay.
if you got it wrong. And most of the time, 99% of the time, if you got it within the vicinity, then I'll give it to you. All right, let's do a nerd. Let's look at some in the homework. The homework in the book. What page is that? Okay, there we go. I need to keep this here.
467.
I can't copy this, so what I'll do, I'll just go back to it. Let me find a problem that looks like a test problem. I'll find a section of the homework that's got test problems on it.
469, dude.
Huh?
469.
So where do we find the hectaacres and all that stuff?
We're not doing that.
Oh,
No, I'm not gonna do, okay. 11, all these right here, do not do acres, you don't need to do those. You don't need to do hectares, you don't need to do square miles, we're not doing those. So let's do 11, 13, well, you can do 11, 12, 13, 14, 17, 18, 20, and that's good enough. That's good for test questions. So let's do, I'm gonna do the even ones for you. I'll do 12, 14, and 18. Write those down. 12, 14, and 18. I'll blow it up for you. And that'll be 3 or 4 that you can do for examples in your book, because that's what I'll give you on a test. I'm not going to give you anything else. This music appreciation.
Would you say 12,
14 and 18. Disney movie.
Sounds like a musical on that.
Have y'all got them all, have you got those three written down? Because I need to go to the conversion table, because I want to get y'all to tell me what the problem is, so I can do it on the white screen. Okay. I wish I could, hold on.
You can't copy paste it.
I was just gonna try to get it, I'm trying to,
Have a dual screen.
don't. What page is it on, the table?
465.
I'll just leave it right there. Oh, the heck with it. All right, what's the first one?
9 pounds to kilogram.
9 pounds to blank kilograms. So 9 pounds over, or is equal to, or is equal to kilograms. We'll get to that in just a minute. What's the second one?
427 grams.
427 grams over 1. And what's the third one?
The ounces.
Okay, what's the third one?
765 millimeters to inches.
765 milliliters.
Millimeters.
Millimeters. I was fixing to say, how you gonna go from that to that? Okay. Millimeters over 1. Now notice, the first thing I did was I changed everything to a fraction. I didn't even write down what I was solving for or what I was doing, because that shouldn't be your priority. Your priority for each one is to put it over 1. Now we go to our handy dandy table and we look to see, we're going from pounds to what?
Kilograms.
Okay, I gotta find my page.
465.
Pounds to kilograms. So what is pounds to kilograms? Is that weight, volume, or length?
Weight.
Weight. There it is. So 1 pound is equal to 0.45 kilograms. Well, if 1 pound is equal to 0.45 kilograms, what are we going to put on the bottom?
1 pound.
That's it. 1 pound equals 0.45 kilograms, and what happens to the pounds?
They cancel out.
And you're left with
Kilogram.
half of 9 is 4.5, so you got around 4.5 or 0.45 or something like that. What is it?
4.05
Okay, 4.05. Good job. 4.05.
kilograms.
And I'm sorry, that's not hard. But the key is to start off with a fraction. If you don't start off with a fraction, you're going to be confused. All right, this one is grams. Let's see, what are we changing to? Grams to what?
Ounces.
So let's look at our handy dandy table. Grams, there's 28 grams in 1 ounce. So let's go back. 28 grams goes where?
On the bottom.
On the bottom. Equals what?
1 ounce.
And what happens to the grams?
They cancel out. Divide.
And that's going to be 427 over 28, which is something
15.25.
15.25.
Ounces.
See? Now how hard is that?
The next one's hard.
All right. Now the next one. It says millimeters to what?
Inches.
So we got to go back to distance. Millimeters to inches. Oh well, inch we got is centimeters. So we gotta change, or we can change it when we get finished, but I'm gonna change it during the problem. 1 inch is equal to 2.54 centimeters. So you just watch and do what it says. 1 inch is equal to what?
2.54 centimeters.
Okay, so, well, centimeters, we don't have centimeters, we got millimeters. Let's go up to King Henry died. King Henry died, meters, liters, grams, drinking chocolate milk. So I would change millimeters into centimeters before I even start, because the conversion is centimeters to what? What is it? Inches. So,
Millimeters.
okay, so change the millimeters to centimeters. So
That changed the problem now.
You'd have to change it back.
they're equal. They're equal to the same, they're equal.
So,
Yeah.
Yeah, if you have 1 centimeter on your ruler, there's 10 millimeters in a centimeter.
Yeah,
So it's the same measurement.
okay.
Okay? So, you're just changing the units. Let me give you another example. Okay, 3 feet is equal to what?
No,
Is it changing anything?
no.
It's not changing anything. It's just changing the units. All right, so I'm gonna change millimeters to centimeters. So what I gotta do? Move the decimal
to the left.
1 point, so that'd be, so I'm gonna cancel through this, and I'm gonna say 76.5 centimeters over 1. Now what? Well, centimeters is gonna go on the bottom, and what'd y'all say
2.54.
equals what?
1 inch.
And you get 76.5 divided by 2.54, what is that? What does that come out to?
I haven't done it yet.
Herbie,
Oh, goodness.
Our brains can't work as fast as you talk, okay?
30.12.
30.12 inches.
And that's rounded up.
And that's how you do dimensional analysis.
Is that for all of the conversions? You have to fraction it and then divide it?
Get a fraction, and then, let me give you an example I always give my students. I did a physics lab at Clemson one time, and we were supposed to make a rat trap car. You could take a rat trap and do anything you wanted to with it, but it had to make itself move by the rat trap, by the spring on the rat trap.
You serious?
That's the physics. That was the whole lab, and your grade depended on several things of that rat trap car. How fast it went, that got points. How light it was, or how heavy it was, that deducted, and how much force you could get out of that spring. And that was your whole grade.
Oh my God.
Okay, so we had a fast car. Our car, we had a trial, and you had to go 10 feet. And our car traveled that 10 feet, I think, in 3.2 seconds. Now, how do you know it was 3.2? Well, we did 10 trials, and that was the average. Okay? We did 10 runs of it.
Were you a student or were you teaching?
I was a student.
Your battery's running out.
Oh, gosh. I forgot to plug it in. There, how's that? Okay, so 3.2 seconds was my average, and that's how fast the car went. Now, right now, y'all know how fast that is?
No.
No. Because why? You're used to what?
Miles per hour.
Miles per hour. So change that to miles per hour. So what's the first thing you do? Well, it goes 10 feet in what?
3.27.
All right, now change it. Well, what do you got to do? You got to find how many seconds are in a minute, how many minutes are in a what?
Hour.
Do those unit conversions. Remember, you can only go diagonally. And this is a good drill for you to think, because you gotta put everything diagonally to get everything to cancel. So how many seconds are in a minute?
60.
So 60 seconds over what? 1 minute, and then what will cancel?
That's 70.
Okay, but then you gotta count, now you got feet per minute. And I just told y'all how many feet were in a mile. How many?
Oh, God, really?
5,280. I was gonna give you that. 5,280. And finish it. We put butter on our, because we couldn't use any petroleum products, so we used butter on our axles for our wheels.
You couldn't use YouTube to find out how to get it done like we can.
Huh?
You couldn't use YouTube to find out how to do it.
No.
We could, like, we were.
Yeah,
trying
y'all
to do it.
can.
We was like, how do you make a right car?
Oh,
Trying to get these little designs and everything.
There was one group, bless their hearts, and they were all girls.
In the class?
No, in one of the teams.
Oh, okay.
And all of them were, and don't get mad when I say this, they were the Oompa Loompa cheerleader type.
That's hilarious.
Dumb as a post. I mean, they were. They're like, oh my God. And you ought to seen their rat trap.
Did they paint
It
them
was all crooked, the wheels were not, that thing wouldn't go, it wouldn't even finish the 10 foot. All right, so you said there's 60 seconds in a minute.
Yes.
And what dictates what goes where?
And that's the units.
So what goes up here?
Minutes.
60 minutes is one what?
Hour.
So now we got feet per what? Minutes cancel, seconds cancel. Now we got feet per what?
Hour.
Per hour. Well, we're almost there. Now we got to cancel the what?
You gotta cancel an hour.
5,280 feet in what?
1 mile.
And the feet cancel. So somebody take the calculator. Let's see, that's going to be 3,600 times 10 is 36,000. Divided by 3.2 times 5280. And tell me what you get. What'd you get?
594 and a bunch of zeros.
I think you did multiplication. 36,000 divided by parentheses 3.2 times 5280 close parentheses. It's going to be around 2 miles an hour, somewhere around there. 2.5 miles per hour or something.
Hang on. $2.13.
2.13 miles per hour. What dictates this problem?
2 point, yeah, that's what I got.
These dictate. You could care less about the numbers. You've got to make the units cancel. And if the units don't cancel, you're not doing the right thing. Now, the numbers have to go with the unit. You can't switch. You can't go, well, I don't like the way that looks, so I'm going to put 1 second is equal to 60 minutes. You can't do that. You can't just switch the numbers and keep the units canceled. You can't do that. There's the kite, there's the tail. Wherever the kite goes, the tail goes. So if you put seconds on top, the 60 goes with that. If it goes on the bottom, then it goes on the bottom with the 60. But the units to where you come out with what? Miles
The measure.
per hour. And if you get this, if you get the miles per hour, then you've done everything correctly. But if you get hours per mile, you might as well start over because you haven't done it correctly. Okay? On a scale from 1 to 10, this is about a 7. I'm not going to give you anything more complicated than this. But like I said, if you keep... Now, could you have put the 1 mile is equal to 5,280? Could you have put it right here? Yes. And then got rid of your time. That's fine. You can do it anyway as long as the units cancel out. And that's chapter 8. Now let's look at chapter 9 and I'll show you what's important there. This is the only section that will give you problems in chapter 8 because you haven't seen it. The other 2 chapters, the other 2 units I'm not going to spend any time on because I think y'all should be able to add up sides. Really do. Alright, so let's look at the next unit, which is 9, and let me see what I'm going to cover there. Where's my favorite content?
Points, lines, planes, and angles.
No, I'm looking for the, oh, there it is.
Oh, it's geometry.
Here we go. Alright, chapter 9. Let me see what's important there. 9.4. I'm going to cover 9.1 to 9.3. So make a note, 9.1 to 9.3. So I'm going to take off the homework for 8.3 and 9.4.
We don't have.
So you don't have to do it. If I don't cover it, you don't have to do it.
9.4 wasn't on our syllabus.
It's not on it?
No.
Okay, well then we don't have to cover it then. Alright, 9.1 to 9.3. So let's look at that. Now some of these I'm not going to cover because all you got to do is look at a definition board. I'll show you what I'm talking about. 9.1. Let me get out of this. Make sure you know what a point and a line is. I'm not going to cover too much of that. I think y'all know what a point and a line is. Make sure you know what a line segment is versus a line. A line segment has 2 dots on the end of it, where a line has 2 what? Arrows. I mean, you see what I'm saying? I'm not going to insult your intelligence with doing these. I'm not going to do unions and intersection. That's not necessary for... Now, we're going to cover angles. Alright? Any 2 lines that intersect will form a what? An angle. There's 2 angles, 3 angles that actually we will go over. And that is straight angle, a supplementary angle, and a complementary angle. What are they? Well, a straight angle is 180 degrees. So let me get my handy dandy. 180 degrees would be that line right there. That's 180 degrees. A acute angle would be less than, and I'll make it purple. That's an acute angle. And a obtuse angle is more than what? 90. And I'm going to take, I can't draw, can I draw a dash? Yeah. Dash line here. There's your 90 degrees right there. Now, can y'all also tell me what the word is for 90 degrees? Up to 90 degrees.
Right angle?
Up to 90 degrees. What can that be called? Well, that can be called a right angle. It can be called perpendicular, and it can be called complementary. Complementary is the word you're going to see. Up to 90 degrees, meaning 90 degrees or what? Less. Up to 90 degrees, that's the dashed line. So from this line right here to this line, that's 90 degrees. Anything in that area is going to be called less than the right angle, less than perpendicular, or complementary. Well, what about the other guy? Well, the other guy, okay. There. I have to click on it and then click back on it. There we go. And I want to Control C and Control V. And we're going to move that over here. What about more than 90 degrees? Well, past 90 degrees, we're going to be talking about obtuse angle. Oh, acute also. You need to put acute over here. Acute with an A and then cute. That's basically what it is. I wish I could work on this. I don't know why it's not letting me. Every time I click on it, it goes away. There. So, more than 90 degrees, you're talking about an obtuse angle. You're talking about more than 90 degrees, which we call, anybody know the word? Supplementary.
So it's not supplementary, but meaning they're together equal to 180?
Mm-hmm. When you see the word supplementary, you're talking about 180 degrees. Because 180 is more than what? 90. Question? Alrighty. Now make sure you know those three words, because I'll give you problems and they'll say, is this a supplementary angle or is it a complementary angle? Or is it a right triangle or is it a acute triangle? That's the kind of questions I'll give you. There they are, right there. On page 484. Now, if I tell you that the complementary angle of DBA is 90 degrees, DBA, and I tell you that this angle is 28 degrees, then what's this big angle right here?
It's 90 minus 28.
90 minus 28. So that's how you find that angle. And that's how they do it right here. 90 minus 28 is equal to 62. If I tell you that the supplementary angle DBA is given and you have angle DBC is 28 degrees, then what is angle EBC?
Subtract 28 from 180.
Exactly. Those are two test questions right there.
Easy.
Huh?
I said easy.
Yep. What is it? Easy peasy.
Does that mean we don't need to stay for the last half hour? Do we know how to do it?
I'm fixing the end plans yet, but we still got to go over 9.2 and 9.3 Monday.
Yeah, that's Monday. My week sucks, so.
Alright, I want y'all to look at example 4. And I want you to read that for homework. Whenever you're doing your homework, I want you to read example 4. And we'll finish up 9.1, 2, and 3 Monday and Wednesday. Okay? We'll at least get 3 units under our belt. Alright, y'all get out of here. Have a good day. See y'all when? Monday?
This room,
Yep, this room I'm gonna finish out because I haven't had a computer glitch at all.